Okay, so this video here is going to be on line graphs. So in our previous video we looked at column graphs and dot plots. This video here we're going to be looking at these graphs here, which are quite familiar in regards to ones we've probably seen before, and they are called line graphs. So these will be the points that you'll need to write down, the key learnings here. And the first thing I want you to write down is that you need to understand that line graphs can often be used to estimate values that are unknown. So here, if we have examples here, if we wanted to know, the sort of weight and the time, if we wanted to know maybe around this area, you can use these line graphs to help us estimate or guess the unknown value. So that's really what they're used for. So write down these key points here, and the first is that the variables on both axes should be continuous numerical data. So see down here we have 1, 2, 3, 4, 5, 6, and then we have continuous on the side there. So both axes need to be continuous numerical. So in the previous videos where we did column graphs, they had the favorite colors are red, green, etc. That won't work necessarily with line graphs. You need to have that continuous numerical data. The next key point is that a line graph consists of a series of points joined by a straight line segment. So as you can see here, they've drawn the points in, and then they've connected those dots using a ruler, preferably, to connect that, so we can see that line there. Time is often shown on the horizontal axis, which we will look at an example here. And a common type of line graph is the travel graph, where we see time is shown on the horizontal axis, the distance is shown on the vertical, and the slope. So see here we have 0 to 1. The slope of that angle shows us the intensity or the speed, and we'll look at another example of that from there. So here we're going to do a couple of questions. We're going to construct one and then interpret one. So the first one here is the temperature in a room is noted at hourly intervals. Again, so we have continuous numerical, so I'm going to be able to put these together, and the temperature at these degrees. So I'm just going to create I'm going to present the result as a line graph, and then I'm going to use that to estimate there. So I'm just going to quickly create that, and then I'll get back to you. Alright, so here is a line graph that we have created, and again I've put it's important that I've done those simple things we've looked at in the previous video. So you need to make sure you have a labelled axis, a title. I've got the scale here on both sides, so numerical continuous going up and across. And now we can now that I've constructed that, I can answer B using that line as a reference. So B, it says use your graph to estimate the room temperature at 12:30 p.m. So I can go across here. 12:30 is in between 12 and 1, so it's this point here. Just follow up that line, and I know that my intersection will be around here, which is about 20 degrees Celsius. So that gives you a good example of how you can use a line graph to estimate unknown values. Now let's move on to how that we can actually interpret a line graph. On the right, I have a travel graph which shows the distance travelled by a cyclist over 5 hours. So I've got my continuous time here on the right, and the distance travelled in total going up here on the left. So question A is, how far did the cyclist travel in total? So he's gone for 5 hours, and the total distance he travelled, here is his highest point, which we know is 30 kilometres. Question B, how far did the cyclist travel in the first hour? So I just need to look at this first hour point here. So from 0 to 1, he travelled a total of 15 kilometres. Question C says, what is happening in the second hour? So he started from 0 to 1. In the first hour he's travelled 15, and then between hour 1 and 2 there's been no movement in the distance. So basically that it means he's either stopped or he's resting. So he hasn't moved at all in that second hour. So he's either resting or he's just stopped for some reason. Now D, when is a cyclist travelling the fastest? So here, this is where it's really important where we begin to interpret. So in the first hour he travelled 15 kilometres, and he's then rested, and then there's a gradual increase from there between hours 2 and 5. So I know that due to the steepness of this line here, that's when he's been the fastest, or that's when he's travelled the fastest due to the steepness of this line. So I can comfortably say that when is a cyclist travelling fastest, in between the 0 and first hour, because that's when it is the steepest line, as we've seen. In the 5th hour, how far does the cyclist travel? Okay, I'm going to go along here. So in the 5th hour, that is in between 4 and 5. Okay, so it's this point and this point. I can see that it goes up approximately 5 kilometres. So final answer there for E is 5 kilometres. So that's how you construct a line graph and also interpret one. Make sure you have these key points down, and over the next few videos we'll start to look at these other types of graphs. Thanks guys.